For our retake video, we're going to go through two quick examples on solving quadratic equations using the quadratic formula. When we're thinking of the quadratic formula, the song is going to the tune of Pop Goes the Weasel. And I normally will sing it. You probably are going to hear me sing it in class a bunch over the next few weeks. But if you want to just say it in rhythm, you would say x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. And so in order to finish this unit, you have to either sing it with me or you can just say it in rhythm, but you have to do one or the other. So let's go into a few examples where we're solving using the quadratic formula. Our first example is the polynomial 4x squared plus 7x minus 15 is equal to 0. Since we're equal to 0 already, we do not have to do any simplifying. We can just start by finding the a, the b, and the c values. Our a value is 4 because it is with the x squared. Our b value is 7 because it's with the x. And our c value is negative 15 because it is the value that is by itself with no variable at all. From here, we need to write down the quadratic formula, which once again is x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. And now we should plug in our a, our b, and our c value using the quadratic formula. So x is equal to negative 7 plus or minus the square root. 7 squared is 49 minus 4 times a, which is 4, times c, which is negative 15, all over 2a, 2 times 4. From here, let's simplify. Okay? X is equal to negative 7 plus or minus the square root. Okay, so let's do some simplifying here. 4 times 15 is negative 60. So negative 4 times negative 60. Well, 4 times 6 is 24. So 4 times 60 should be positive 240. Positive 240 plus 49 is equal to 289, all positive. And then 2 times 4 on the bottom is equal to just 8. So we get x is equal to negative 7 plus or minus. The square root of 289 is just 17 all over to 8. And because we're looking at the plus or minus, it means that we almost always will have two solutions. So our first solution is going to be with the positive, or the plus 17. So I'm going to get x is equal to negative 7 plus 17 all over 8. Negative 7 plus 17 is 10. 5/4. There we go. And that simplifies to the decimal 1 1/4, or 1 25/100. Our negative solution, move the negative down here. So I'm going to do x is equal to negative 7 minus 17 all over 8. So I get x is equal to negative 24 over 8. So x is equal to negative 3. And just like the first video, I'm going to check this on Desmos to see if my graph ends up being correct. So this looks a little crazy. So I'm going to zoom in here. So my left number is negative 3, which is correct. That's the one I wanted. The number on the right, I'm looking for 1 25/100, which is what I get. Therefore, I have the right answer, solving using the quadratic formula. Let's do one more. For this problem, we do not have an equation that's set equal to 0, so we need to move whatever is on the right side of the equation away from that side to create 0. Now this time it's an x, so I'm going to add 18x to both sides. This creates a 0 on this side. And so I get 2x squared plus, and I'm going to put the x second, 18x plus 39 is equal to 0. So we got some big numbers going on here, but we can still solve this problem using the same tools that we had before. So we need our a, our b, and our c values. A value is 2, b value is 18, c value is 39. So our quadratic formula is x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. And now let's plug it in. Now I'm going to pause the video here to have you try to plug it in and see what you get. After simplifying, I end up getting this. The problem is, unlike before, the square root of 12 is not a rational number. It's an irrational number. So knowing what we learned from sections P2 and P3, we need to simplify this radical as much as possible. So I'm going to get x is equal to negative 18 plus or minus. Now 12 can be split up into the square root of 4 and the square root of 3. The square root of 4 is equal to regular 2. Square root of 3 stays all over 4. Now this looks worse than what we've been doing. But the truth is, this actually is going to save us a step because we don't have to simplify as far. But what I can do is I can divide every one of these numbers by 2. I'm not going to obviously simplify square root of 3. But what I end up getting is negative 9 plus or minus 1 root 3 all over 4. And now, just like before, I am going to solve by making a positive and negative solution. But I can't go very far this time. My positive solution, using the right pen, is negative 9 plus the root of 3 all over 4. And I can't simplify any farther than this. I can make a decimal, but I actually can't simplify this any further, which means my negative solution, by the same token, is going to be negative 9 minus the root of 3 all over 4. And once again, I can make a decimal, but I cannot solve any further than that. So when you go to Desmos and you look at this answer, it's going to give you a crazy decimal and another crazy decimal, and your job is to then plug that into a calculator, probably mine, the one I have in my classroom, and make sure your decimal matches their decimal. But everything else about this problem stayed exactly the same. As always, if you have any questions, please let me know.